Okay, in Unit 1, we're going to introduce functions, talk about their domain, evaluate functions using the notation, graph functions, obtain information from the graph of a function, also find the domain and range from its graph and where it's increasing, decreasing, and identify the intercepts. All right, let's start with an example here. So, a medication is prescribed based on a patient's body weight. The recommended dosage is 0.5 milligrams of medication per kilogram of body weight. So what are the inputs and output? I'm going to write a function here that represents the relationship between input and output. That's what a function is. So the input would be the body weight. Okay, so I tell the doctor how much I weigh. The doctor tells me how many milligrams of meds to give me. All right, so that's the relationship. Input, output. We'll call this x, and we'll call this f of x. This is the function notation. So it's 0.5 for every kilogram of body weight. So this is in kilograms, and this is in milligrams. So the function would be 0.5 times the input, the body weight. Okay, so if I weigh 70 kilograms, I plug that in. Input, body weight in kilograms. Output, whatever you get when you do the operation of the function. In this case, take half of the body weight, and that's 35 milligrams. Okay, so this is function notation. This is f of x. Sometimes you'll see this as y equals 0.5x. You might have seen that before. These are really the same thing. This is just different notation for the output. So what is the domain? Okay, so domain are all the invalid values for the input. Okay. So the question would be, what's the smallest input? Well, you got to start at 0. It can't be negative, right? So the domain would be, x would have to be, I would say, it's got to be greater than 0. And then it has to be less than what? Well, we're not really sure here. I mean, a pretty heavy person weighs, let's say, I don't know, 300 pounds looks like it's 136 kilograms. So if you weigh, I don't know, 600 pounds, that's a very large person. You're coming in at 272, something like that. But that's kind of too complicated, right, to figure out what the biggest weight is here. So we'll simplify and we'll just say it has to be positive. Let's just start with that. We'll talk more about this as we go. But this just means weight can't be negative. And I guess the problem with this would be it could go on forever. But this is the domain of the function. So right now we're going to say the domain, this would be acceptable. Or you could try and like cap it. You could say, well, it's got to be greater than 0, but it's got to be less than, I don't know, 300 kilograms. That's a very large person. We're going to talk more about interval notation as we list. This is a set. So the interval notation for this would be from 0 to infinity. The interval notation for this, we would say from 0 to 300. Okay, so either one of these would be correct. I think we'll just keep it basic for now and go with that one. Okay, so we can talk about what the function means. How does it ensure patient safety? Well, we're not going to give too much drug to the patient as long as we have some kind of formula or function for it. Here's an interesting one. What if we needed to reverse the process, solve for weight? So I have f of x equals 0.5x. What if we wanted to rewrite the function? Well, what you'd have to do is we wanted to solve for x, right? Reverse the process. So this is equivalent as 1/2 x, right, if you want. And then I could multiply both sides by, this is my function. Another way to write it, 0.5x is 1/2 x. I can multiply both sides by 2, do a little bit of algebra here, and that solves for x, right? 2 times 1/2 is 1. So x would be 2 times f of x, where this is the milligrams. If for some reason you do the milligram, right, that is if I had 35 milligrams of drugs, how much does the patient weigh? Well, if I plug in 35, that would now be my input, and that would 2 times 35 would be 70. Okay? That would be x. So we'll talk more about that as we go through functions as well. The point of that question is the input is milligrams, the output is body weight. But if we want, we could say the input would be body weight and the output would be milligrams, and it would look something like that. Okay, more on that later. The key takeaways from my first example is what's the connection between input and output? We just wrote a little function, and then the domain is going to be a big topic moving forward. All right, so that's your function notation. So I'm going to just move right along to this next example, and we're going to practice with this. Here's my new function, f of x equals 3x squared minus 2x plus 4. What's f of negative 2? Well, the notation means I plug that value in everywhere I see an x. And then I do the operations. I square it, I multiply it by 3, I multiply it by 2. So our order of operations, that's 4, 3 times 4. That's 4, and I end up with 12 plus 4 plus 4, which is 20. Input and output. Sometimes you'll see functions written like this, x and y, or that could be f of x, all right, like a list of functions. So an input of negative 2 would give me an output of 20. How about 3? F of 3 equals 3 times 3 squared minus 2 times 3 plus 4. That's 27 minus 6 plus 4. 27 minus 6 is 21. Plus 4 is 25. So an input 3 gives me an output of 25. Okay, let's do this one next. This is an interesting one. So we'll have to use our algebra skills sometimes to evaluate functions at non-numeric values. Okay, so a non-numeric value, we know what f of x is, but what's f of x plus 1? Well, I treat it the same way. I say 3x plus 1 quantity squared minus 2x plus 1 plus 4. All right, and now I got to be real careful with x plus 1 squared. It's not x squared plus 1. It means x plus 1 times itself. I'll go ahead and distribute this guy. Minus 2x minus 2 plus 4. And then what happens when I square x plus 1? I got a FOIL. So I get 3 times x squared plus 1x plus 1x is 2x plus 1 minus 2x minus 2 plus 4. A lot of work here. 3x squared plus 6x plus 3. If I distribute the 3 minus 2x minus 2 plus 4, I guess that's plus 2. And then from here I combine like terms, right? Those are like terms and these guys are like terms. And I get my final answer, 3x squared plus 4x plus 5. All right. More on functions applications. We always want to apply the math that we're doing. The number of unread emails in Anthony's account is 110. The number grows by 25 a day. So he's starting with 110 and 25 per day, or 25 times t would be how I write that function out, right? After 1 day, he's got the original 110 plus 25. After 2 days, 2 times 25 is 50. He'd have 160, and so on. So what is n of 14? So n of 14, this is after 14 days. That's what it means. It's the number of emails Anthony has after 14 days. And what would that be? That'd be 110 plus 25 times 14. That would be 250 plus 100, 350, if I did that right, plus 350 equals 460. And that's, again, how many emails after 2 weeks or 14 days. Let me just make sure I did that math correctly. That's 25 times 14, 350. Okay. Good. The next video we'll look at graphing functions.